In this example, we're going to use the library enumeration feature in StarDrop's Nova module in combination with R group analysis to generate a virtual library representing a potential new lead series. This will be based on a previous series and explore the impact of a change of scaffold and variations in a side chain while retaining the substituents at two key positions. First, go to the Nova tab. Then, load the accompanying example file, Factor 10A Inhibitors. This dataset contains a series of compounds with experimentally measured potency against the Factor 10A target. First, we'll perform an R group decomposition of this series to generate some groups to substitute on a new scaffold. Select the first row in the dataset and click the R group analysis tool on the toolbar. On the Select Scaffold page, draw around the fixed scaffold for this series, which will be highlighted in blue. Click Next to confirm that the correct substitution points for R groups have been identified. On this page, you can define additional substitution points, variable atoms, or fragments, but we don't want to do that in this case, so click Next again. Finally, we can give this analysis a name for future reference. And click Finish to complete the analysis. The resulting R group decomposition is shown in the dataset. Now we're going to enumerate a new virtual library for a similar series based on an indole core. Select the first row in the dataset again and click the arrow button on the Nova tab to start the enumeration. In the Nova wizard, first select the Library Enumeration option and click Next. The Sketch Scaffold page will be shown containing the selected member of the series. You can, of course, sketch a new scaffold by clicking the Reset button, but in this case we'll edit the displayed compound to create the scaffold for our new library. First, we want to erase the groups at the substitution points to leave the scaffold for our new series. For small groups, you can erase atoms and bonds using the Eraser tool. For larger groups, use the Select tool, draw around the regions you wish to delete, and click Ctrl-X to cut them from the structure. Next, modify the core of the original series to change it into an indole. Select the Bond tool and click on the bond to change it from single to double. Next, use the R button to add R groups in the R1, R2, and R3 positions by clicking on the atom to which they should be connected. We will also define some variations in the scaffold, in this case to the linker between the core and R3. Using the X tool, click on all of the atoms which comprise a contiguous region in the linker. Click Next to move to the Define R Groups page, where we can list the groups to substitute at each point. Click on the plus button next to the X1 box and choose Sketch to define the first X1 fragment. We'd like to include the same linker as in the previous series, so we can simply accept this, give it a name if we wish, and click OK. Once again, click on the plus button next to the X1 box and click the Sketch option to draw a different fragment. In this case, we want to define a longer linker, so erase the bond between the nitrogen and amide carbon and insert an additional methylene. You can give this linker a name if you wish, and click OK to add this to the list of X1 linkers. Now, click the plus button next to R1 and choose the Select option to open the library of predefined substituent groups. In this, you will see that the groups derived from the R group analysis of the original series are available. Clicking the arrow next to an entry will expand the list to show the individual substituent groups in that list. Tick the box next to the list of R1 groups from the original series to select all of the same groups for this position and click OK. Now click the plus button next to R2 and choose Select. Choose the list of R2 groups from the original series and click OK. Now scroll down to see R3, click the plus button and again choose Select. There was only one group in this position in the original series, so select this and click OK. We will now sketch an additional substituent for the R3 position. Click the plus button next to R3 and choose the Sketch menu option. Draw a 4-chlorophenol group. The star indicates the attachment point of the R group, so the fragment must link to this point. You can give this fragment a name if you wish, then click OK to return to the Define R Groups page again. You should see that the resulting library is estimated to contain 748 compounds. Click Next. If we wish, we can automatically calculate the properties of the compounds in the resulting library and select a subset of compounds according to a given property or score. In this case, the library will be quite small, so we could easily enumerate all of the compounds. But as an example, we will select the 100 compounds with the lowest predicted log P for further analysis. Tick the Select Compounds box, choose the method by property, and choose to select compounds with low log P. Now choose Select the best 100 compounds and click Next. Finally, on the Enter Dataset Name page, we can give the resulting library a name and click Finish. An indicator will show the progress as the library is enumerated, the log P is calculated, and the compounds selected. When complete, the resulting library will appear in StarDrop, and all of StarDrop's capabilities can be used to select compounds or consider further improvements. For example, by switching to the Models tab, we can run models to calculate additional properties. And we can use the Visualization tab to visualize the distribution of properties for different R group combinations. For example, selecting two R group columns will plot an SAR table. We can color the circles in the SAR table using any property in the dataset by clicking on the color bar in the key. Choose the property from the drop-down menu in the Format by Property dialog box. In this case, we'll use Hurg inhibition as an example. By binning the property values, each circle in the SAR table becomes a pie chart. To download the example files and step-by-step guidelines to try this example yourself, visit the tutorials section of the Optibrium community.